Okay, students, so now we're going to talk about postulates. So in geometry, rules are accepted without proof. They're called postulates or axioms. The following postulates, they're found in a book written by ancient Greek mathematician Euclid titled The Elements. If you can remember, we talked about the elements the other day. So we're going to go through these postulates. So they're so simple, we just accept them as fact. There's a lot of things in math. Have you ever wondered, how do we know this is true? How do we know that this works? So on and so forth. Well, we actually prove everything in math. There's theorems, there's proofs. That's the way we know it's 100% true for all cases. And we're actually going to spend a whole unit proving math theorems. But you can't actually prove everything. If you try to prove everything, then you run into a problem called circular reasoning, where you just kind of go in a circle. So there needs to be some foundation where we just accept these as fact. Just think about if you try to make a peanut butter and jelly sandwich from scratch. Well, to actually make a peanut butter and jelly sandwich from scratch, you'd first have to create the universe. Well, you can't do that. So you just have to accept some things like the bread's already going to be made, or even if you make the bread, well, the dirt, you're not going to make the dirt where you plant the seeds to grow the wheat. All right, so this is just the most basic things that we accept as facts. So through any 2 points, there exists exactly one line. So 2 points create a unique line. So if I draw a point here, call that H, and draw a point here, D, I can only draw one line that will go through both these points. And look, I kind of did a crappy job. We'll make these points bigger. But there's only one line. All right, there's no other lines. I can't move that line. And then postulate 2, a line contains at least 2 points. So ultimately, it contains an infinite amount of lines. I'm going to do a follow-up video with this with Legos after this to kind of further the explanations. But we need at least 2. And once you have 2, it's defining the unique line. Of course, there's infinite, but the 2 make it unique. It makes it go a certain direction. The orientation is cemented in the ground. So that's why that's like that. So this is the real basic stuff right now. And plus, you guys can probably read these and predict what's in the blank. If 2 lines intersect, then their intersection is exactly 1 point. All right? So we have this line going over here, and then this line going over here. Boom. It's only going to exist or intersect at 1 point. We'll name that point Z. And we'll be seeing pictures like this. This is actually a very powerful picture. We're going to talk about, or we're going to use this picture all throughout the year. Remember, we're still building the foundation. Through any 3 non-collinear points. So they're not, or non-collinear means they're not in a straight line. There exists exactly one plane. So they have to be non-collinear, because if they were collinear, then you can spin the plane around the line that they form. And we're going to talk about this in a cool follow-up video. So 3 non-collinear points make up one plane. I'm going to call this plane plane M right there. And then a plane contains at least 3 non-collinear points. So it's literally just the same picture. It's going to look like this. Same thing with a line, where 2 points make a line, but then there's infinite amount. 3 points make a plane, but once you get 3, there's actually an infinite. All right. Postulate 6. This is just saying, well, if 2 points lie on a plane, so we got some plane chilling right here. There's a point here. There's a point there. If 2 points lie on a plane, then the line containing them lies on the plane as well. So then, boom, you have this. And then I'm going to try to draw something really cool right now. just a little fun follow-up. Let's this will be good moving forward. I'm gonna copy, paste that down here. When you see something like this, dotted lines means that it's behind. So like that's almost like this black line that I just drew. It's going straight through the plane. It's a vertical line. Dotted lines mean behind. It helps us analyze a two-dimensional picture as a three-dimensional figure. And then this one, this is really going to test your drawing skills. If two planes intersect, then the intersection is a line. Wow. So what this one always throws me a doozy. Let's see. Actually, let me think. How do I want to do this? And draw this right here. Or actually, you know what's probably the easiest way to do this? Is let's just draw a cube. I'm good at drawing cubes. That's one of my skills. I'm good at a lot of things. Drawing's one of them. Math. So the best way to probably think about this is we have this blue face of the cube, which is on top. Blue and orange look good together. And this orange face, which is on the left. They're intersecting to form a line. So when planes intersect, they form a line. And remember, planes go on forever and ever and ever. All right, so these are postulates. They're so simple, they're just accepted as fact. All right, so I'm gonna do another follow-up video and kind of show this with some Legos.